Hey guys, what is up? Ewan here, and today I'm going to be teaching you how to make a procedural wood texture in Unity's shader graph. The project is set up with Unity's lightweight rendering pipeline. As always, this is because I want to be able to load up this shader on any device. Okay, so there's a couple of things that we're going to have to do, and first off, I think I'm going to create a custom node. So I'm going to call this lines node, and you'll see why when we make this shader. But let me open this up. Okay, so we're going to have to make our own custom node. So we're going to change this to code function node, and I think we'll have to import something. Yeah, we'll have to import Unity's shader graph. We can delete all this, and then simply implement abstract class, and then here we're going to need to make the title of our node. I'm going to say custom nodes, and then lines node. Okay. Now here is where we're going to have to declare the method within the class that is going to have our custom nodes function in it. So we need to return get type, get method, and then here is the name of the method. So I'm just going to call it lines node method, call it capital E, and then we're going to put a comma here, and then we're going to do binding flags dot static or binding flags dot non-public. So this is just a standard one that's used in the Unity documentation. Here is just the method, and I'm not entirely sure what these do, but it will be explained more in Unity's documentation. So next, what we need to do is we need to add a constructor, lines node, and we're just going to do name equals lines node. Simple as. Next thing is we're actually going to make the function that our code for our custom node will be in. So lines node method, and what we need to do here is we're going to have a couple of things. So it's going to be in the first slot. I need to do these first. So slot 0, binding none, and then we're going to have a dynamic dimension vector. I'm just going to call this A, and then slot 1, binding dot none, and then we're going to have another dynamic dimension vector and call it B, and then finally in slot 2 or 3 depending on how you're counting, we're going to have another dynamic dimension vector out, and I forgot one thing, we're going to need to put out here. Okay. So we're now going to return a string, and we're going to do at and then two inverted commas, and that's because with an at in front of the two inverted commas, you can make it a multi-line string. So we're going to have a couple of squiggly brackets, and then first thing is we're going to have a scale float. Now I'm just having that equal to 10 because it's a number that I found that I don't really need to change that much, but if you want to add the functionality yourself, you can just simply add another dynamic vector in here, call it C, and have this equal to the scale, and you're good. So what we're going to do is we're going to have times A by the scale, and then we're going to have out equal to smooth step 0.0 0.5 times B, or sorry, 0.5 plus B times 0.5, and then we're going to have the absolute of we're going to have the absolute of sine of a point x times essentially pi, so 3.141415, and then we're going to have b, we're going to add b times 2 to it. Now at the very end of everything, we're going to times this by 0.5. And that's it. What this will do is essentially, when we're using noise, it's going to turn it into like a height map you'd see on a map rather than just simple noise. So let's go down here and create a new shader, PBR graph, and let's call this a wood shader. Right click on it again, create material. I'm going to call it wood shader as well, and then I'm going to create a plane in the scene, attach the wood shader onto it. Now let's open up the shader graph. Here we are. Now let's first create a couple of properties. Okay, first let's create us a couple of properties. So let me move this out over here, stretch it open a bit, and what we're going to want is two colors, and one vector 2 and one vector 1. So the first color is going to be the wood color, and by default I'm going to have it to like, yeah, a nice dark wood. The second color, you're going to call it dark map, I think. And we can leave this at black, or I'm going to put this to yellow actually. The next thing that we're going to add is we're going to add a vector 2 called offset. And then finally, I'm going to add a vector 1 and call it smoothness. Now the vector 1 for smoothness, I'm just going to drag in here and attach it to smoothness on the PBR master. Now let's start with the shader itself. So I'm going to go over here, I'm going to create a couple of nodes. I'm going to create a tiling and offset node, and then I'm going to create another actually, and you'll see another two actually. So we're going to have 3 lines, because how we're going to make this wood texture is we're going to have 3 layers to it. We're going to have a background layer, we're going to have the layer with all the knots on it, and then we're going to have a sort of nitty gritty layer just to add a little bit more texture to the wood. Okay, so let's go up to the first layer, which is going to be the background layer. Actually, I think before we all do that, drag the offset property from the shader and just attach it to all the offsets of the tiling and offset. This will mean that you could change this property and you'll be able to change how the texture looks. So the first node we're going to create is a Vronomi. I've never learned how to say that, and it always messes with me. So what we're going to do is we're going to drive the first tiling and offset into the UV map, and then we're going to go to the tiling and we're going to change the X to 2.21, and we're going to change the Y to 0.12. Very simple, and that's all we need to do for the moment. The next thing is on the second layer, we're going to create a gradient noise node. We're going to drag in the tiling and offset from the second layer. And for the tiling, we're going to leave X as 1, and we're going to change Y to 0.17. Now, what we're going to do next is we're going to add our custom node. So in here, it'll be under custom nodes and lines node. And we're just going to drag the out into A. And we're going to set the B to 0.47. Let's just save this. And it seems like we've got an error. I'm just back. I figured out our issue. I only had 1 bracket after the 2 here, when you're supposed to have 2. And that will fix the issue that you're having with the shader graph. So let's go here and get right back into it. So now already you should be able to see that the shader graph looks a lot more like the knots, because you can see the circles here, which is good. That's what we're looking for. So what we're going to do is that we're going to create a blend node. We're going to put it up here, and we're going to drag the lines node into the bottom blend and the out of the Veroni into the top one. And then we're going to have opacity to 0.03, or maybe a little bit more than that. Let's see. I think this is about good. So 0.27 is what we're looking for. So now that we've got this done, what we're going to do is we're going, 0.27. What we're going to do is we're going to create another gradient noise down here, and we're going to have the tiling move over, and what we're going to do is we're going to have the X at 1 but the Y at 0.25, and then the scale we're going to have it 58, and I found that that creates a nice sort of textured effect. And what we're going to do is we're going to create another node, and we're going to have it a contrast node, make sure you click on contrast and not constant. So I've done that multiple times. We'll drag the gradient noise to the first one. And then here for the contrast, we're going to have it at 7.04. Next, what we're going to do is we're going to create another node, and we're going to have it a lerp node, and we're going to drag the blend from the first two noises and the contrast from the last one together. And then what we're going to do is we're going to create a vector 1 here and drag it onto t, or time of the lerp, and this is what's going to be about 0.03. So just to clarify, this should be around 0.3 and this should be around 0.03. Okay, next we're going to move this over just to give us some more space, and we're going to create a node, a multiply node. We're going to attach the lerp to the multiply, and then we're going to drag our wood color down here and attach this to B for what we're multiplying it by. So now you can already see that this looks really like wood. So we'll just drag this into the albedo, and we can save this. Let's go to our material, and already you can see it's starting to look like wood. Now my aim for this project is to get us something looking like polished wood, so you could have it on counters in your game, or use it on chairs or something along those lines. So what we're going to need to do is we're going to need to make a normal map. Now this is kind of hard for a procedural texture, because normal maps kind of rely on you having the full texture and you sampling different parts of the normal map to get. Essentially, a normal map is another type of height map, so you need to know, but it's all relative. So what it does is it tells the shader the relative height of the point compared to other parts of the shader. But what we can do is we can simulate this, since as it's a procedural shader, this is going to be made on the fly. So we won't know the full map. And as we can't wait until the texture has been generated, we will just have to simulate it. So let's go back into our shader graph and go here. And what we're going to do is we're going to create a white balance node down here, and we're going to drag it from the lerp, and then we're going to turn this into a purple shade. So we're going to go for minus 0.21 in the X for temperature, and then for the tint we're going to change this to 1. Nice and simple. And then we're going to create another node, and we're going to have a replace color node. So let's drag this in, and this is where the dark map color comes in. So we're going to replace the color from the black to the dark map color. Now what I've found is a 1.17 is quite good at finding roughly the right places, and a fuzziness of about 0.10, 0.1, 0.08 is good. I go for 0.08, and then we'll drag this into the normal map. So if you've ever seen a normal map, you'll know that it looks bluey purple, and the colors around the bumps is what indicates the height and the lowness of the texture. So as you can already see in the preview, it is quite shiny, and that is the shader done. Everything else will be tweaking in the material. So let's exit out of this, and you can already see this looking a lot more like wood. It's got the shininess that you expect to see from polished wood, the black bits anyway when you look at it from an angle at light. So let's go to our project, our wood shader, and go to the smoothness, and we can make it shinier, we can make it less shiny. I'm going to make it slightly less shiny, and I'm going to go to the dark map, and yellow and blue are good colors to get a different sort of shininess. So I'm going to go for a bright blue, I think, judging by this. Maybe not. I think the yellow was probably right. I'll go to about here. And here we are. This is our procedural wood texture, our polished wood, using only the shader graph. Now, the reason why I have the offset is that now we can move it sideways, or move it up, move it down. You can move it in a Z direction if you wanted, but the Z and W won't do anything because it's a vector 2. So there you go. So what this allows you to do is use the same shader, but if you were to have an object like, I don't know, a sphere and a sphere and a plane next to each other, and you didn't want the textures to be the same, you could have two different materials and just change the offset on both, so you don't have to worry about the two materials looking like they're the exact same texture. So okay guys, thanks for watching. Tune in next time where I'll be probably messing around with the Unity shader graph again, because I'm having a lot of fun doing this and figuring out new ways to use it. This I used some sort of old thesis papers from different universities in America to figure out how I should do this. So yeah, tune in next time, and like, comment, subscribe, all that good stuff. Share with your friends if they're interested in making shaders and stuff, and I'll see you guys next time. Bye.